All right. Hey, everyone. Today is day 20 of Math 133. So we are going to be covering two things today. So the Chapter 10 review and the Chapter 10 project. Okay. Um, we don't have a lot of time left before the final. Monday we're gonna do the Chapter 11 project, then the Chapter 11 review, and then we are going to work on the sample final exam. The final exam is on August 6th. And I'll be sending out a survey to ask if you're taking it with me versus taking it in the testing center, just like with the midterm. We'll probably talk a little bit more about what to expect on the final exam on Monday. Okay. Okay, so today though, we're covering two different things. So the chapter 10 review, we're going to start with that, and that is going to start on page 489 in your course pack for the chapter 10 review. Okay, page 489. Yeah. All right, cool. I'm going to go over a couple hints for you, and then we'll do the chapter 10 review. And then we're also going to work on the Chapter 10 project, which is connected to our M&Ms and Skittles data. Make sure you know where that is, because we're going to need your numbers. You can't just copy mine. Okay, Chapter 10 review. So a researcher carried out two-tailed hypothesis. All of this stuff here you'll find on page 210. Okay. uh, and page 204. Okay. Figuring out p-values based on z-values. Okay. So we've done that kind of thing before back in chapter 7 where we had z-values and we were connecting them to probabilities. Okay. On your normal curve. Um, so next, we have a couple different experiments, a couple different studies that we've done, and we're deciding if we want to reject the null hypothesis. Okay. Uh, so the way that you tell if you reject the null hypothesis is you compare your p-value and your alpha. Okay. So if the p-value is less than alpha, then you would say yes. Okay. All right. Uh, of these studies, which one has the lowest chance of a type 1 error? Which one has the lowest chance of a type 2 error? Okay. You'll find this on page 197. Okay. Um, so a type 1 error, the chance of a type 1 error is the alpha value, which they already give you. Chance of a type 2 error is actually after alpha is beta. So it's the beta value. Okay. Um, and statistically significant, you'll find that on page 203. Okay. Um, this one, page 208, we talk about practically significant versus statistically significant. Okay. All right. In June 2020, Johns Hopkins researchers released a study that in the US there was about a 38% false negative rate for COVID tests. That's horrible. That is a very high false negative rate. So page 198 for these. Um, so uh, yeah, okay. Page 198. All right. Next page is page 490. Okay. All right. So for this one, we're filling in this chart here. Okay. Um, so as we're doing this, we're comparing reality to the decision. Okay. Now, keep in mind that the reality is something we don't necessarily know, okay? Because we are testing a sample. We're not testing everything, but we have to make a decision based on our sample, okay? And when you make a decision, yes, we're going to do this. No, we're not going to do this, right? We're in this case, we're installing engine parts, okay, into these airplanes. The decision to yes, install it or don't install it is based on the sample. And since it's a sample, since we did not check everything, there's a chance that we make an error, right? Type 1 error, type 2 error, okay? Um, so, yeah, so this one, the decision is whether we install it or not, okay? And up here, we're is strength, okay? Strength of the engine part, okay? Anyway, you'll find information on this chart on page 196 through 198. Okay. All right. P-value is less than the level of significance. Level of significance is our alpha. Okay. Uh, these two are on page 203. These two are on page 196. Okay. All right. Page 491. Conventional wisdom says that the average means we're looking at mu, okay? We're looking at a population mean. Uh, and movie length is 2 hours, okay? So 2 hours is 120 minutes. You guys know that. I think it's not true. Uh, to check your claims, random sample of 25 movies, okay? Um, we find that the average length is this, standard deviation is this. Um, okay, so these are samples. Average length here is the sample. We don't know the average movie length because we're not checking every single movie. Okay, standard deviation, this is the sample standard deviation. We don't know the standard deviation of all movies. Okay. Are the requirements for conducting a hypothesis test satisfied? So just like before when we were comparing to the central limit theorem or comparing if we can build confidence intervals, it's the same steps to check, okay? Uh, Random, independent, and normal, okay? Uh, all right. Normal here is a little bit different because they actually gave us a graph. That's fine, okay? Anyway, all of this is on page 241, okay? All right, so once you've checked if you get three yeses, then we can build a confidence interval. Okay, so not a confidence interval. As I said, if the central limit theorem is correct, is satisfied, then yeah, then it means you can do all kinds of things. You can build confidence intervals, you can do hypothesis testing, all of this cool statistics stuff. Okay, so okay, so no, first you state your hypotheses. So you have your uh, null hypothesis and your alternative hypothesis. Okay. So this one is going to be mu equals 120 minutes. Okay. And this one is mu is not equal. Okay. So this is going to be a two-tailed test because we think this is not true. Okay. We don't know whether we're not claiming whether it's more or less. We're just saying, no, 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 it's not 120. Okay. Um, we, uh, if we were saying it was longer, we would go greater or less, depending on which direction we are testing. Okay. All right. Number two, state our alpha. Okay. What's that going to be? Number three, uh, we get p-value. Okay. So that t-value is going to be some formula. Okay. All right. And then we do substitution. Okay. And then we do some stat crunch. Okay. Set stack, because that's going to give us our p-value, right? And this is our two-tailed test. Okay. Once you've done that, you take your p-value and you compare it to your alpha. Okay. Which one's bigger? And then finally, you can say your result. There is blah, 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 blah. Okay. All right. That's for doing hypothesis testing. Okay. A lot of steps, but all right. All right. Last page for chapter 10 review worksheet is page 492. All right. So CNN article stated that less than a third. So less than a third, that's our hypothesis. That's our alternative hypothesis. Okay. Um, so if they're saying it's less than a third, your null hypothesis is always that it's equal. Okay. Your null hypothesis is always going to be it's equal. Okay. Your whole alternative hypothesis is always either going to be not equal, less than, or greater than. In this case, it's less than. Okay. So this is going to be a one-tailed test. Okay. So, I mean, so when you're actually doing these experiments, like in the real world, like how do you tell if you do a one test or a two-tailed test? So it usually depends on the context. It depends on what you're trying to do. So like, for example, if I was trying to compare to ad campaigns and I was trying to figure out which one was more successful, okay? Um, I don't know which one is more successful. I don't care. So in that case, I would do not equal. Okay. Although if I have like an old campaign I'm running and I've been running it and I want to see if I should start doing a new campaign, well, you need that new campaign to perform better than the old one. Otherwise, there's no point in changing it. Okay. So in that case, I would need a one-tailed test where I want to see that the new campaign is greater than the old one. Okay. So it really depends on the context of the situation. It also depends on the context of the situation, what alpha you're going to use. Okay. How accurate do you need to be? Okay. All right. So for this part, same thing. We're gonna check random. Did we say random? Yeah, we did. So right here, random. Okay. We want to make sure it's independent. That one's usually no problem. Normal. Okay. So did we sample a big enough sample size? So you do N times P times Q. Okay. So in this case, our P is 1/3. Q would be 2/3. And that has to be bigger than 10. Okay. All right. If all that's good, then we can do our hypothesis testing, right? So step one, H0, P equals 1/3, right? We already did that. Equals dot dot. H1 dot dot. P is less than 1/3. Okay. 2, we pick an alpha. Okay. And when you're picking an alpha in the real world, you need to do it before the experiment, because if you do your hypothesis testing, you do your sampling, you do everything, when you get to the end, if you have a p-value that's, let's say you have a p-value that's 0.02, 2%. Well, then if your alpha is 1%, then you're not going to reject the null hypothesis, okay? But if your alpha is 5%, then you would, okay? So you can't just like do the experiment and then decide, oh, well, I really want to reject the null hypothesis, so we're going to set our alpha to 5%, okay? You need to set your alpha ahead of time, okay? All right, since we're doing P, we're using Z values, okay? But there is still a formula for that. You substitute in your numbers. All right, you get your result. Okay, from StatCrunch. See if I can draw a better normal curve this time. So, uh, so you get your p-value, compare that to your alpha value, which one's bigger, okay? And then you can write out your result or your interpretation. There is blah, 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 blah. Okay. All right, cool. All right, we're gonna jump back to page 49 and work on filling this in, okay?